Hello folks, well we're going to start with a trade customer's repair, which is a Harrier CBX. It comes on. That confused me. Make sure these are somewhere, and we'll just run through what it's actually doing right now. So we'll plug our standard replacement mic in. Switch picture in picture on, and we're on channel 20. Let's go into transmit. So we'll start off on the 3-watt scale, so we should have beyond full scale deflection, which we have. So we're now on the 30-watt scale. There's 30 at full scale deflection, there's 5, and so we're looking at 4. So it's doing 3.2. Pop that on channel 40, 3.1. Needs to be within really 0.1 and 3.5. So it's not balanced as well as it ought to be. So go back to channel 20. It's doing 1.105 amps, which is exactly what you'd expect for that output. And in low power, if I can find the switch, it's doing 1.1 watt. How bizarre. So that's supposed to be 400 milliwatts. Deviation, it shows 4. We'll recheck that on the test set behind me. We'll do that. Test set's been on for a couple of hours, so we'll look at the frequency counter on that. That should be all nicely warmed up, ready to give a correct reading. Let's have a spot on. Yeah. Spot on. Well, that's one thing we're not going to have to twiddle. 27.79124. Right, so we'll now go to receive. I'll just dial that into the signal generator. That P range has actually gone back to the customer today after 9 months. Right, see what it's doing. We need to plug the test equipment speaker in. My meter's cluttering up the bench. Well, apart from the cutter that's cluttering up the bench. But it seems we're going to use that very, very shortly. It can stay here for another 10 minutes. Right, let's look at the SINAD meter. Which the poltergeist has moved. Camera off. Switch it on. And let's see where we can get. I'll tell you what, that's ever so good. Am I in the right mode? Yeah, it looks like I am. Yeah. It's doing 0.37. And for 10, 0.33. And for 20, if it'll do it, will, 0.71. Squelch. So I like radios to be able to, as well move to the attenuator, I like radios to be able to squelch out up to S9. S9's 100 microvolts. So there's no hard and fast rule on this, but some sets you end up with no signal whatever will ever break through the squelch when they're at full, and that is obviously far from ideal. So 1, 3, 10, 30, 100, so it hasn't come in. 300, and squelch never ever opens. Never opens. Right, we'll do the opposite. So we'll set it to, we'll put the signal generator to standby, set the squelch to threshold on the front panel, see when it comes in. It's just coming in at 1 microvolt. We could say it's 1.05 microvolts. So let's look at the meter. It's supposed to be S9. It's supposed to be 100 microvolts, and it's 300 microvolts. So that would be said to be a lazy needle. Meter lamp's working, switches are, we'll come back to that. That's working, just check PA. Testing. Testing 1, 2, testing 1, 2. And it works on the mic gain control, so that's fine. We've just got a few more switches to try before I can tick that off. It's not come with a mic, and the speaker works. So we just need to check where we are on transmit. So when you key up, bearing in mind the radio's doing 3.2 watts, into a dummy load, we're supposed to get something near on the meter when we're not in PA. It says 2.5. So we'll bring that right. Right, so it works, but it needs a little bit of adjustment. Now, what's annoying about the Harrier, I'll cut the power, is that lovely radio, but as an engineer I have to take more screws out, don't I? Because you can't just take the speaker lid off, you've got to take both lids off with 8 screws. I just feel so quick with the normal screwdriver that I don't bother with these electric screwdrivers. I bought one once in the 90s. It was a Power Devil one, and it was anything but. I think it was about a 2.4 volt thing, and it wouldn't even unscrew the case screws of a video recorder, which were already loose. So, yes, I've had various electric screwdrivers, and then you've had them 2 years, and the batteries are knackered, and I'll just. As a church organist, I've got pretty good strength in my wrists. So keep the bottom on because of its capacitive effect. Pop the speaker to one side. Storage bin for lids just arrived at my knee. So I'm having a quick look to make sure we've got no distressed looking capacitors which would show overvolts or overheating. So that all looks fine. That looks cracked. Let's hope it isn't. Right, I'll take picture-in-picture back off, and we'll start with this meter. See if I can remember the switch, the setup procedure. Just pop the power back on. Channel 40. That's a good earth strap. VCO. So resistor 4, far side. What we got? 4.47. let's write on the meter display 4.47 plus, and transmit 3.4. Just needs a little bit of a twiddle there. So it's supposed to be 4. And on transmit it's supposed to be 4. This is where I have to key the mic. What you're supposed to do is to have a dummy microphone plug that you put in, which has got the transmit wire pins linked out, and then you don't have to do this shuffle. I've been shuffling this for 40 years. There we go. Back. Just check receive. Yeah. So now we need to check that on channel 1 it's somewhere like between 1.8 and 2.3. So with receive 2.3, transmit 2.28. That's fine. So it's in log. So if you overlook the VCO, you can end up with channels dropping out. You know, like nothing working above channel 38 or something like that, or the opposite, or in cold weather, and so on. So this and the other Cybernet chassis used in the Amstrad type set, and the Mustangs, and it's not the Amstrad chassis, it's the Cybernet chassis used in the Mustangs. The VCO is even more critical on those. But I find with the Maxcom sets, very rarely ever out. And you have to add 3 or 4 components to be able to read it anyway. Uniden ones can drift as well, but that's because they have capacitor issues, I expect. Right, let's go through transmit. So put picture in picture back on, and we will key up, and not be in low power, not be on channel 1. There he goes. So, what we got? That one. Make sure these are in. We're doing this on channel 20, so it's the centre of the band. We need to make sure it's absolutely centred on channel 20, so it's not different power on. You see that one's out on higher or low channel. So now I've got 3.5 watts. So now we move to the scary ones, and we have to find the tool that's going to fit today. So these have to be set to maximum and quickly, because the radio cannot sync and source the kind of power it can achieve, which should be more than 4.4 watts for long. 3.6. 3.7, 3.8 is not the best example. This is going to be difficult to set up because it isn't doing 4 watts. As I've said many times before, this test set is selective, so it's only looking at the transmit power on this band. So the second harmonic of 54 megs and the third harmonic and so on, it's not taking into consideration. So on a normal power meter, you're always going to get 0.4 of a watt more, even if it's calibrated right. So if I say a radio is 3.6 watts, it's going to be 4 watts on a normal meter. But this is the way the government inspectors would test. So, you know, but if I sent this back and I say it's 4 watts, most people would read it as 4.4. So when I tell you a radio is 3.6 watts, it's going to be 4 watts on a normal meter, but it's still 3.6 watts. So still trying, we're about 3.8. Okay, so I'll just run through this once again, just see if we can get that fraction more. When it's cold, it will do a fraction more, and we're a whisker away from 4 watts. So it's about 3.8 with the radio warm. So what we're going to do is we need to, the service manual says, adjust this one clockwise till we get 4.4 watts. Well, we can't get 4.4 watts. So we're going to have to move it clockwise until we see a movement. There's our movement. And the service manual says adjust this one anti-clockwise until we get to 3.8 watts, but we're allowed 4 watts. They say 3.8 so it can get through customs. I continuously get questioned about why the sets come out of the box low power, because they have to be inspected at customs, and if one set was reading over 4 watts then the whole batch will be rejected, so they always make sure they come in at lower power than that. So there we are, that is about 3.85 with the set warm. So it will be doing 4 when it's cold. Now then, so 3.85 on channel, I'm going to write this down on here as what I'm reading now. So 3.85, channel 40, 3.85. And channel 1 3.9. There you go. So that's pretty well balanced, and on anybody else's meter that will read about 4.25. So at low power, this power light makes absolutely no difference to your range. It's so minimal, you wouldn't even tell the difference between 3 and 4. So let's go to low power. It is there. Switch to low power on my test set, and let's see whether we can have a twiddle from 1.2 watts. It's a bit iffy that. We'll just give it a quick squirt. It's probably what it's doing at 1 watt because it wasn't working very well at the right point. There's 4. Milliwatts. Don't know what we're doing on the air test this evening, unless we can cram it in earlier, because the snag is there's a lot of road works on that road. Right, so we've now got it drawing 1.143. So we've gained half a watt, and it's only drawing 40 milliamps more. So it just shows it was a little bit out. So deviation was stupidly high. We like to have this one in the centre position, which it more or less is. I'm going to knock it down here to get the oscillator on the job. On the wrong thing anyway. Set it to there. Whoa, that's spot on this test set, because I don't trust it on deviation. So I'm just going to plug into the test set on the bench behind me. I could use the whole test set on the bench behind me, but there's no cameras on it, so I couldn't, could I? There you go. So my test set's playing silly whatsits. There we go. Turn that off and save some electricity. Plug back into this test set. So, looking at that, if it was reading 4 on this test set, probably chances are it was 5.5. So it's 2.2 now, 2.2 to 2.5 kilohertz maximum. VCO is 4 plus 4, and the frequency is staying the same, 27.79124. So now we'll work on the receive, which is already really good. No, we won't. We'll do the transmit meter. So what's it reading now when I key up? Banging across. There we go. So we'll now set that to reading 4. When the set's cold, it will indeed be 4. This could be the quickest tune-up for months. So I'll switch to the SINAD meter. Manually move the camera because the poltergeist has altered the camera. This room is in fact haunted, so we used to have this room as a bedroom, and my friend Mark came to stay, and there's an ensuite bathroom, and it's supposed to be a master bedroom, and he said I was having a pee at the toilet and something behind me clapped their hands on my shoulders and said, "You'll be alright." So I gave him a bit of a turn, and Mr. Chippy came to stay for a weekend, and you know, he had this room, and he said I had a funny experience. I woke up and there was somebody on top of me holding me down by my shoulders saying, "You'll be alright." So anyway, we've got some very powerful lighting in here. It's all parts of being British, isn't it, this whole area was, I mean, Ancaster, a mile away, was a Roman fortress. There was a castle here, and the church is built on the site of the Roman temple, you know, and the church was built 1,000 years ago. So there's a lot of history, a lot of strange things. Whoa. Right, let's get this tuned. We'll start with the detector, put a 100 microvolt signal, and let's switch this camera, which I've just bothered to put square, switch it to the oscilloscope instead. I'm too bothered telling you tales. Absolutely spot on. Now we'll go back to that camera, which I'll just have to move. If I hadn't have checked it, it would have been miles out, we all know that. Right, so I want the SINAD meter to read, and the squelch to be not doing anything. Have it about there so we're not saturating the receiver. See whether we can improve on it. That was a dramatic change, wasn't it? Give you a signal for these. and the hidden one under the wiring. No, they're all fine. It was that one, wasn't it? It was a bit out. Okay, so we'll have a new SINAD reading. If I turn it off, we'll turn it back on again. I'm going to change scales because it's not on my normal scales, on a more sensitive one. So now at 0.22. And 0.4. So you hear a gnat coughing 100 miles away. Right, let's deal with this squelch. Squelch to full. 100 microvolts on the signal generator. That's now right. Let's put the attenuator on so you can see where we are. 100 microvolts. So now we'll check it at the sensitive end. Signal generator to standby. Park it at 0.3. Set the squelch on the radio. And 0.95, the threshold. And 100 microvolts, the threshold. Let's just do the meter. So it's 100 microvolts. And it now is 100 microvolts. So that retune on the receiver has brought the meter correct. So I don't need to adjust it with the preset there. So fill that in as well. Right, well, it just needed a retune. Quick check back to transmit. Put that meter on so we can all see it. I haven't let the radio cool down as such. We have stopped transmitting for 10 minutes. And that's 3.95 watts on channel 20. So it will do 4 watts when it's cold. We're done. Now, I do have another customer repairing to the trade. We're going to keep that a couple of weeks before moving on to it. It's another Cybernet chassis, and it's a balancing 5-star with its knickers in a twist. We may not be able to sort it out, and it's just the chassis. He's not going to bother getting the rest of it together if it doesn't work, you know what I mean? So see whether we can work some magic on the chassis. But what I do want to do, we've still got this DNT hanging over us, the B40, but Mr. Chip is not being well, as you know, and the bit of that he is doing is holding that job up. So we'll come back if I haven't forgotten about it, but I need to cram some more jobs in. What I want to show you is a CB240 chassis. That's the Alba CBM1, the Harvard 400M, and the Eurosonic Euro 1 and Euro 2. Now, not to be confused with the Eurosonic GT8 68858 types, because they were also Eurosonic Euro 2 but in Roman numerals. The Eurosonic Euro 2, Euro 1 the Euro 1 has a Roger bleep, and the Euro 2 has a switchable Roger bleep. So those 4 sets share this same chassis, which isn't a good chassis, but I haven't seen one for ages. And I was shuffling around looking for a scrap chassis for something or other, probably that DNT base, and I came across a nearly complete CB240 chassis, which I bought in a batch of junk, but the front panel was totally missing. So I said to one of our trade customers, I said to a couple of the trade customers, have you got a scrap chassis kicking around, which is a CB240? And one of them came up trumps. He's actually sent it as a donation, which is very kind of him. We do reimburse postage if people so wish, but customers like him, we just look after him. If they've sent something in, just look after them, something special. Another point, we don't buy radios. People say, I've got a radio for sale, do you want to buy it? No, I'm a service centre. We don't buy radios, we don't sell radios, we just repair them. But we do accept donations to feature on the channel, because some people find it fascinating to see their non-working radio brought back to life. So, that's what's forthcoming. That wants some glue on it. I recommend you get some Bostik. There's the remains of a Bostik. That's really the only one we would recommend. So there we go. Fantastic, super duper. We're going to piece together a previously scrapped Harvard 400M, which uses this CB240 chassis. And hopefully between the chassis which has been sent me by the other dealer and what I've got and what parts we've got, we'll be able to resurrect that into a full working set. He's got a case half, the top half. I've got a case half, the bottom half. So between us, we've got a full case. And I think it'll be fun to resurrect a really, really scrap chassis set, just for my own fun. Perhaps I won't be able to do it, but it'd be nice if we could. Now, the electronics those sets use is the same as the Harrier and the Harvard and the Alba 40-channel walkie-talkie, which are not the best sets. Those of you in the know will know they use a Motorola MPSU 31 output transistor, which is expensive and difficult to get, and can often be the end of the life of the set if that fails. So there we go. As it happens, I did buy some for £19 each, sometime some years ago. So that's it. They're not a good chassis, they're a bleed over box, and they've got a weak squelch, but I want to show one. I could do Morse on this front panel. So we're on the aerial now.
I just sat in the shed.
Well, no, Roger.
In about with this receiver. Alright. Hey, Roger, yeah, it's a good one.
They're probably at Nottingham, 35 miles an hour. It's about 1:30 in the afternoon on Friday. There we go. What a lovely set. Oh, just the tone control, right?
Oh, there's one here, it's like brand new. Well, you don't get one then, will I? Nice and all.
Yeah, okay, right, well, we'll leave them to it. Perhaps somebody can explain to me why people can't change channel these days. Right. Doing on the air test later. Don't know how we're going to manage that because of the road closures, but we'll come up with something. That set's going to be an absolute cracker, and he says it's not his best. I've got his note here. Here's my not so great condition Harrier CBX. Let's see how it performs. And the answer was, we were able to bring up the transmit. We were able to bring down the deviation. And the thing is, deviation, remember, is the width of the signal. So, although it's going to sound louder, it's only going to sound louder and louder and louder if you've got a bleed over box you're receiving on. So into a Fidelity 1000, at 7 kilohertz, it's going to sound louder and louder and louder and better and better. Whereas on a set with decent filtering, once you go beyond, 2.5 kilohertz, it's going to start clipping, and you're going to be the Norman Collier effect. And of course, that's what's important. That's why it's not like AM modulation. So thanks for watching. Hope you enjoyed looking at a nicely used, good condition for 40 years old Harrier CBX that works really splendidly.